Okay, here we've got Edexcel M3, January 2011, question 3 on center of mass. So here's the question. It's a fairly standard question on finding the center of mass of a volume of revolution, and it's pure maths really. It's integration. So we've got to find the center of mass of the solid that you get if you rotate that region R about the x-axis through 2 pi. So here we go. I'm not going to do all the working while you watch this because it'll be tedious. You'll just be watching me do the integration, and I don't think there's much benefit in that. So I've written the integral out. First of all, we have to find the volume. So that's standard stuff. The formula for volume of revolution, is pi the integral of y squared dx, and in this case the limits of integration are x is 1 to x is 2. So following through this then, the curve is y equals e to the x, put that in and square it. E to the x squared is e to the 2x, so we've got to integrate e to the 2x from 1 to 2. So straightforward enough to do that and put the values in, and you get the expression they're asking for in part A. And then going on, part B wants the coordinates of the centre of mass for 6 marks. So this is the main part of the question. Now the centre of mass of the volume of revolution will be on the x-axis somewhere, obviously by symmetry, so we'll call it x bar 0. And the standard theory here for finding the x coordinate of the centre of mass, finding x bar, is that the total mass times x bar is equal to the integral, or this integral here, pi y squared x dx. That's effectively the sum of all those tiny little disks of mass pi y squared times their distance x from the x-axis. You can look up the theory behind that in your textbook. So we've got the volume from the first part. It's the we've got the mass from the first part. It's the volume here. So all we have to do now is carry out an integral, and when we put the value of y in at the top here, the left hand side is m x bar, and this expression is pi the integral of y squared x dx. Here's the y squared, e to the x all squared, which is e to the 2x times x. And if your eyes have strayed further down the page, you'll have recognized the method used, but as soon as you see an integral of the form x e to the 2x or similar, it's by parts. So integration by parts in a mechanics problem. Okay, so we get stuck in and carry out the integration by parts. Now I'm not going to talk you through all that. I just suggest you pause the video and try working through it yourself. The limits are 1 to 2, and if you've tried working through it by now, you'll hopefully have got on the right hand side an expression like this, which tidies up to this expression. And then there's some more tidying up you can do, cancelling things out. The e squared cancels, and we end up with this expression for x bar. They're happy to accept the decimal version as well, which is 1.66. And that's it. That's the end of the question. So not much mechanics in there. It's really just core maths, pure maths. Let's have a look where the marks were allocated in that question. So in the first part here, there was a method mark for quoting the expression for B, then a method and accuracy mark for putting in the right value of y and squaring it and carrying out the integral. Oh, and an accuracy mark for putting in the limits and getting the correct final answer. So 2 method marks, 2 accuracy marks there. That's the 4 marks for the first part. And then on the second part, Again, there was a method mark for quoting the form of this in black here, this statement about the centre of mass. As far as the integration is concerned, then, we had another method, an accuracy mark for carrying out the integration by parts and getting the correct answer on the right hand side, and a final accuracy mark for getting the right answer for x bar. And that's it. Thanks for listening.